You're the only participant, Tony, right?
Yeah, we're the only participant. Nobody's signed in yet.
Is the presentation on your?
Presentation's on my S drive, yeah.
Okay, so you should be able to get to it from here.
You want to wait?
So I'm gonna wait. We gotta be here 2 hours anyway, so I was gonna wait like 15, 20 minutes
Yeah.
for the presentation.
We could probably mute ourselves. Should probably mute ourselves, right?
Yeah.
I'm not gonna do that yet.
We're unmuted again.
I'm muted.
We're still not muted though.
Got it.
This is the environmental justice hearing for the Rahway Valley Sewage Authority. The hearing is for the Title V air operating permit renewal and for a permit modification application for increase in flare hours. This hearing is being held in accordance with Administrative Order 2021-25, which was signed by Governor Murphy. The purpose of the environmental justice hearing is to give low-income and communities of color an opportunity to have input regarding decision-making relative to environmental matters. We have some of the staff of the Rahway Valley Sewage Authority here. We have our Executive Director, Jim Meehan, our Deputy Director and Chief Engineer, John Bonacore. We have a consultant here, Mike Hober, with the Environmental Compliance Assistant. He's our air permit consultant. We have Doug Reno, who is our plant superintendent, and Janet Thevenin, who is our supervisor of environmental compliance. I'm going to put up, we're going to have a slideshow presentation to go through the elements relative to this hearing.
Which one on?
Yeah,
Okay.
I'm going to work. Oh, it's not on.
It is. It's.
There you are.
You're on.
Was it on during that?
Yeah, you're good.
Okay.
No, he wasn't. Uh-oh.
The bottom left was it's unmuted.
Now it is.
I saw a slash through it though.
Right.
Take it from the top.
Yeah, I think that's a good idea, just in case.
One time. Can you back up like 6 inches or so? So there you go. So your whole face is in there. They can see you talking.
We may have been muted, we're just finding out. So we're just going to go through that again in case it didn't record. This is the environmental justice hearing for the Rahway Valley Sewage Authority in connection with the Title V air operating permit renewal and a permit modification application for an increase in waste gas flare hours. The environmental justice hearing is being held in accordance with Administrative Order 2021-25, which was signed by Governor Murphy. The purpose of the environmental justice hearing and policy is to give low-income and communities of color an opportunity to have input regarding the decision-making relative to environmental matters. We have some staff from the Rahway Valley Sewage Authority here today. We have our Executive Director, Jim Meehan, our Deputy Director and Chief Engineer, John Bonacore. We have Mike Hober, who is with Environmental Compliance Assistance. He's our air consultant, and we use him for air permitting purposes. We have Doug Reno, who is our plant superintendent, and Janet Thevenin, who is our supervisor of environmental compliance. We're going to share screens in a minute and put up a PowerPoint presentation, and we'll go through that. This mouse doesn't like me.
I think it's Zoom.
The Rahway Valley Sewage Authority was formed as a joint meeting in 1928 and became a sewage authority in 1951. The plant site is about 23 acres and is bordered by Hart Street, which is in the city of Rahway and the township of Woodbridge, and Randolph Avenue, which is in the township of Woodbridge. The plant site is actually located in both Woodbridge and Rahway. The majority of the plant is actually located in Woodbridge Township, but the mailing address and main gate is for Rahway. There are 11 member municipalities and 3 customers. The member municipalities are Springfield, Mountainside, Cranford, Clark, Rahway, Kenilworth, Roselle Park, Westfield, Garwood, Scotch Plains, and Woodbridge. The customer municipalities are Winfield Park, Fanwood, and just a few blocks in the city of Linden. The population served is about 200,000 for the entire service area. There are 24 permitted industries which contribute about 5% of the plant flow. Our design flow per our NJPD's permit, that is our New Jersey Pollutant Discharge Eliminating System permit, is for 40 million gallons a day. And the average daily flow that we normally see at the plant is about 25 million gallons a day. We have seen as much as I think about 140 million gallons a day during wet weather. So our plant flow can vary a great deal, but the normal flow is about 25 million gallons a day. This is an aerial view of the plant site. The plant is shown within the red border. There are two trunk sewers that come into the plant. One is the Woodbridge Gravity Relief Sewer that comes in from Randolph Avenue and runs down the eastern border of the plant site. There is a main trunk sewer. That sewer is 42 inches. There's a main trunk sewer that is 72 inches that comes in through an easement at the north end of the plant. And those two sewers tie together at a junction chamber that is just outside our headworks building. This is our headworks building, which has a bar screens, both fine and coarse mechanical bar screens for removal of big solids and rags and large debris. Then there are aerated grit chambers for removal of heavy materials such as grill, silt, coffee grinds. From there, the effluent goes to an effluent distribution box, which is just before the primary clarifiers, and that distributes flow to the 4 primary clarifiers. From there, the primary effluent goes to our aeration basins, where the primary effluent is combined with waste-activated sludge and air in order to perform biological treatment of the wastewater that comes into the plant. The biological treatment will remove biochemical oxygen demand, or BOD, and in the process will also remove total suspended solids, or TSS. The mixed liquor from the aeration basins go to six secondary clarifiers that are used for solid separation, and a portion of the sludge that's settled in this process is returned to the activated sludge basins, and a portion of it is wasted for off-site disposal. The effluent from the secondary clarifiers goes to gravity sand filters, which further remove solids. And from there, the effluent goes to an ultraviolet chamber for disinfection. And the flow then normally is by gravity out to our outfalls. But there is a effluent pumping station in the event that the flow at the plant is high and the tides are high and we can't get out by gravity. The 2 outfalls, one goes off-site through Carteret to Arthur Kell, and the other is on-site and just goes across to the Rahway River. Our primary outfall is the outfall to the Arthur Kell, and the secondary outfall to the Rahway River is only used during high flows when we can't get all of our flow through the main outfall. In addition to the wet, that's the wet end of the plant, there's the solids end of the plant where primary sludge is pumped to sludge gravity thickeners, and waste activated sludge is pumped to rotary drum thickeners. The primary sludge is about 0.5% solids, and the gravity thickeners will thicken it up to about 2% solids before it's pumped to the sludge digesters, anaerobic digesters. The waste activated sludge is about 0.5% solids, and that will be thickened up to about 3.5–4% solids before that is pumped to the sludge anaerobic digesters. The sludge is in the digesters for about 30 days, and then it's pumped over to storage tanks for holding until we're ready to dewater it at our dewatering building, which is at the other end of the plant. From the sludge storage tanks, sludge is pumped to the dewatering building, and there are centrifuges in that building to dewater the sludge and increase the solids to about 23%. Now, from there, we can dispose off site, but normally what we'll do is we will go by a screw conveyor to the cogen dryer facility, which is right next door to the watering building. And there is a sludge dryer, which will further dry the sludge to between 95 and 99% solids. This is also cogeneration engines are in that building, and the waste heat from those engines is used to dry the sludge in addition to supplemental heat from a thermal oil heater, which we'll talk about more later. And once the sludge is dried or just dewatered, it'll go into roll-off containers, which will be hauled for off-site disposal in either a landfill or for beneficial reuse. There are a number of insignificant sources in our air operating permit. These are sources which in and of themselves would not require a Title V permit, but since we do have a Title V permit, they're rolled into it. There's a 275-gallon diesel storage tank, which is above ground, and that's for fuel oil that's used to fuel the backhoe that we have on site. There's a 2,000-gallon above-ground storage tank for gasoline, which is used for fueling on-site vehicles. There are building boilers that are less than 1 million BTUs per hour. For instance, there's a boiler in the employee building, there's one in the admin building, and one in the admin annex that will fall under those building boilers. Another insignificant source is the wastewater treatment system itself. There's volatilization in the aeration process, so those emissions would be covered in the wastewater treatment system. There's 5 polymer storage tanks, which are used to store polymer for dewatering and thickening of sludge. We have an on-site laboratory for wastewater analysis for process control and for some permitting requirements. That laboratory has laboratory hoods for exhausting fumes for certain laboratory procedures. There's 3 infrared heaters, which are less than a million BTUs per hour, and those are in the maintenance building. There are 2 natural gas fired unit heaters that are in the maintenance garage. There's an employee building furnace. There's a laboratory building furnace, and there is a 385-gallon waste oil storage tank. The significant sources at the plant include the sludge digesters, sludge storage tanks, and the waste gas flares. There's also boilers, which are used for process and for plant heating. There's sludge processing, which is the gravity thickeners and the rotary drum thickeners. There's a thermal oil heater, which we'll talk about more later. Cogeneration engines, the sludge dryer, which we mentioned, and sludge processing equipment, which is the centrifuges that are used for dewatering. And there's emergency generators in the event of a utility power outage and a power failure with our on-site cogeneration engines.
Tony, can you just back up and mention the co-digestion of food waste?
We'll get to that when we talk about the storage tanks.
Okay, good.
It also should be noted that the initial air operating permit was in January of 2005. So we've had a Title V air operating permit for 17 years. The potential emissions that we're concerned about at the plant are carbon monoxide from combustion. That's from the boilers and from the cogeneration engine. Nitrogen oxides also from the cogeneration engine and from the boilers. There's volatile organic compounds, or VOCs, which are emitted from the cogeneration engines that are in the exhaust. There are odors that we need to be concerned of, which are primarily hydrogen sulfide and reduced sulfur compounds. Those odors are generally associated with the sludge processing, and we have odor control, which we'll talk about later, to eliminate the possible of off-site odors. Sulfur dioxide is also a concern, and that is generated from the biogas that's produced in the anaerobic digesters and from the, or actually from the cogeneration engines from burning the biomethane gas. And we're also concerned about particulates, again, from the combustion process. There are 3 sludge digesters on site. They are 1.1 million gallons each. There are 4 sludge storage tanks that are 294,000 gallons each. And there are 2 waste gas flares that have a limit of 4,346 hours per year based on a 12-month rolling average, rolling total. There are also, which I guess we should mention that didn't mention before, there's 3 gravity thickeners. 2 of them are used for primary sludge thickening, and 1 is used for the storage of vegetative or food waste, which we add to the anaerobic digesters to increase the production of biogas for burning in our cogeneration engines and for generating electric for use on site, and generating waste heat for our sludge drying process. There are 3 process boilers that are used on the site. There are 2 primary service boilers, which are 6 million BTUs per hour each. One of those boilers is set up only to burn natural gas. The other boiler has a dual fuel burner, which can burn either digester gas or natural gas. However, we normally only burn natural gas in that boiler. There's a boiler in the pump and blower building, which is 4.84 million BTUs per hour. And that boiler is also set up to burn either natural gas or digester gas. And when that boiler is online, it's normally burning digester gas. There's a thermal oil heater in the cogeneration dryer building that heats thermal oil for the sludge drying process. It's a supplemental heat that's provided in the event that there's not enough waste heat from the cogeneration engines to dry the sludge. That heater is normally operating, and it operates on natural gas. Our air operating permit has a requirement to do an annual combustion adjustment, or an ACA, on the 3 process boilers and on the thermal oil heater. The purpose of the annual combustion adjustment is to optimize combustion of those units in order to minimize the emission of nitrogen oxides and carbon monoxide. For odor control, we have a multi-stage scrubber, excuse me, which scrubs off gases from the gravity sludge thickeners. The thickener that's also used for food waste and for the rotary drum thickeners. This scrubber uses sodium hypochlorite as an oxidizing agent to oxidize the sulfur compounds and sodium hydroxide for pH adjustment. The scrubber is a 3-stage scrubber, with the first stage being upflow, where the exhaust gases flow upwards, and there is a scrubbing media that consists of the water, the hypochlorite, and the sodium hydroxide, which trickles down. And then the next stage is a upflow stage. And then there's a 3rd stage, which is another downflow stage. From there, the treated air is vented through an exhaust stack on top of the rotary drum building. There's a number of operating requirements in our air permit associated with the multi-stage scrubbers. Those permit requirements are to ensure that the scrubber is working properly. There are pH limits for the stages. There was a ORP or oxidation reduction potential limit associated with the hypochlorite for the scrubbing solution. There are pressure drops from the gravity thickeners and from the rotary drum thickeners to make sure we're pulling enough air from those units. There's a requirement to monitor the pressure drop across the scrubber itself. And there is a requirement to monitor recirculation rates of the scrubber medium. One of our major sources, as was mentioned before, is the sludge dryer. The dryer dries sludge from 23% solids coming off the centrifuges to between 95 and 99% solids, normally around 95%. As was previously mentioned, there's heat transfer from the thermal oil heater and also from the waste heat from the cogeneration engines. There is a condenser which is used to extract moisture from the off gases, and then those off gases are bubbled in the aeration basins. There are also there's a transporter and a receiver, which is a pneumatic system for conveying the dried sludge from the dryer building to the roll-off trailers for off-site disposal. The transporter and receiver both have bag houses to control dust emissions from those units. There are 4 Caterpillar engines, which are 2,131 brake horsepower each, and they each generate 1,541 kilowatts of power. In connection with the cogeneration engines, there is a digester gas treatment system for removal of sulfur and siloxanes. The biogas that comes off of the sludge digesters goes to what are called sulfur treat vessels. Initially, the medium in those vessels was sulfur treat, but we've been using carbon with great success. And then from there, there's also a chiller to remove moisture from the biogas. And then there are 4 siloxane vessels that are used in pairs to remove siloxane to protect the engines from damage. There are oxidation catalysts on each of the engines to destroy carbon monoxide and reduce carbon monoxide emissions. They also reduce volatile organic compound emissions. The engine design is a lean burn design to minimize nitrogen oxide emissions. So there is no catalyst associated with reduction of nitrogen oxides. The engines are designed to have those emissions reduced. The air permit requires compliance stack testing every 5 years. In addition to the compliance stack testing, there's a requirement to do periodic emission monitoring quarterly. The periodic emission monitoring is done with a handheld gas analyzer, and we monitor for carbon monoxide, nitrogen oxides, and for oxygen percent. As was mentioned before, there are sludge processing equipment. It consists of centrifuges. There are 3 centrifuges. One is permanently out of service and hasn't been used in a number of years. The centrifuges have limits on volatile organic carbon compound emissions, and a limit on odor, and a limit on the throughput of sludge. All those limits are explicitly stated in the permit. There are 2 Baldor emergency generators, which are 2,181 kilowatts each. Those emergency generators, as I said before, are to power the plant in the event of a utility power outage and a power outage with the cogeneration engines. So normally those engines would only run for testing or maintenance purposes, but there have been situations where we've had a power blip or a power outage and the engines have started up. The permit limits the sulfur content in the fuel that's used, the diesel fuel, for the emergency generators to 15 parts per million by weight. And as I stated, they're only operated for maintenance or emergency conditions. When we operate them for maintenance purposes, the air quality is checked on a state site, on a state website, to make sure that the air quality is acceptable for running the engines. As I said at the beginning of this presentation, one of the purposes of the presentation is because of a application for a permit modification to increase flare hours. We have an existing limit in our permit of 4,346 hours for both flares. We have 2 flares, and that's a combined total. We're requesting an increase to 6,519 hours. Normally, we would not use those flares. They're just for emergency purposes. Normally, the biogas is burned in the cogeneration engines. However, in the event that the cogeneration engines are down, we have to have a way of getting rid of the digester gas, and that way is by burning it in the waste gas flares. We did recently have a problem with the engines. There was a backfire, and it was a significant backfire that caused damage to the exhaust piping and the exhaust breaching. And we had to redesign our supports for those elements and get that equipment in here and installed. The engines required some repairs, and the engines were actually out of service from August 19th until May 25th, 2022. Because of that, there was a need to do an inordinately amount of flaring, more than we normally would. Normally flaring would be minimal, but since the engines were out of service, we had to do a fair amount of flaring. And we did exceed the permit limits for 1 month back in May. And that's the reason why we are looking for an increase in the flare hours. The gas has nowhere else to go. If we don't burn it in the flares and we can't burn it in the engines, the only other possibility is to exhaust it to the atmosphere, which we don't want to do that. That would certainly have more environmental impact than burning the waste gas. The RNG project is for renewable natural gas. That is a project that we have in the works. We're in the process of planning that, and we're in the process of negotiating contracts with the gas utility and with the contractor. The renewable natural gas project will involve injecting the biogas after it's cleaned and processed into the natural gas pipeline. Once that project is in place, there'll be virtually no need to, there should never be a need to do waste gas flares. But I guess I should never say never.
Yeah, short times for maintenance, Tony.
For maintenance, your purpose, but no, hopefully the engines will be up and operating, and we'll be able to use the gas in the engines in that case. But in the unlikely event that the engines are down and the RNG project is not in operation, then we would have to use the waste gas flares. But again, that should be minimal. Jim, did you have anything else you want to add on that?
The food waste receiving station is something that we did 40 years ago, and we really were a little bit ahead of the curve. It is part of the state's energy master plan right now that wastewater treatment facilities that have additional capacity are supposed to accept food waste that's generated within 25 miles of them, I believe. And we're, I think, the only wastewater treatment plant right now currently participating in that actively. I believe Southern Monmouth Regional Sewage Authority just began a trial. So we're really the only wastewater treatment plant that's actually doing what the state's energy master plan has called for.
The public comment period will be open until September 3rd. In the event that anyone has any comments that they would like to make with regard to renewal of our permit or our application for additional waste gas flare hours, they can write to me, Anthony Jancarelli, at Rahway Valley Surge Authority, 1050 East Hazelwood Avenue, Rahway, and the zip code is 07065. Or you can send an email to A. Jancarelli, GenCarelli, at RahwayValleySA.com. I'll just leave this up for a few minutes.
Yeah, the only other thing I do have to add too, Tony, is any revenue that's generated as a result of us accepting food waste, whether it be through creating clean energy or a tip fee, is returned back to the ratepayer in a reduced rate for wastewater treatment services. And that's it. That's
Yeah.
pretty much it. Thanks, Tony.
Okay. We'll just keep it open. We'll keep the public hearing open until 8 o'clock, started at 6. So we'll have a full 2 hours and we'll wait to see if anybody calls in. Nobody has called in yet.
I think what he said, we could just share the screen again. Back to that comment page. And we can just shut off the microphone and speaker and camera.
Yeah, that's right. That's what they want to
Don't, no. Go back to,
comment.
Go back to share screen.
I thought you wanted me to mute the,
yeah, well, mute us and shut off the video. No, go down on the bottom left.
mute over here.
Yep, hit mute.
This thing's on like a West Coast delay.
Yeah, it's really bad.
Okay, it's, wow, that's go on. It's 5 minutes or it's 6 minutes now after 8. The public hearing for the environmental justice for the Title V operating permit renewal and for the increase in flare hours, the permit modification application. This hearing is now closed at 8:06. There were no participants from the public, but the public comment period will stay open for 30 days and will close September 3rd.